Our Introduction to Solutions podcast has us revisiting some of the topics that we've covered previously in this chemistry course, and mostly it just stands as a way to organize the different types of solutions as well as define some of our vocabulary terms and solutions. So let's start with the basics on solutions. We have both pure substances and we also have mixtures. Pure substances are going to be elements and compounds. These are things that have their own physical and chemical properties. They cannot be physically separated from one another. So, for example, sodium is an element. It cannot be separated into a smaller component and still retain the same physical and chemical properties. An example of a compound would be sodium chloride. This is chemically combined. You cannot separate the sodium from the chlorine without using chemical means, and therefore it has its own physical and chemical properties. Mixtures are when we have two or more of these pure substances. They can be elements, they can be compounds. They're physically mixed together. So think about stirring them together. They're not chemically combined. Their composition can vary. You may see one substance of one color and another substance of another color, but these can be separated by physical means. So a good example of this would be salt water. If you think about adding salt to water that you would gargle or ocean water, we could evaporate the water off, leaving the salt behind. That is a physical means of separation. It wouldn't take us doing anything special, applying electrical current to separate those. They can be separated by physical means. Another example I like to use is at Subway. When you get to the very end of the sandwich line, they ask if you want salt and pepper, and they've got those combined in the salt and pepper shaker together. If I were to spill that out on a countertop, that's a physical mixture because I wouldn't want to, but I could physically separate the salt from the pepper, but I couldn't separate the sodium from the chloride in the salt. That would take electrolysis. Let's talk about some more definitions. So we're going to be talking about solutions this entire section, and a solution contains both a solute and a solvent. The solute and the solvent, keep in mind, because this is sometimes challenging our thinking, it can be a solid, a liquid, or a gas. So your solute could be a solid, a liquid, or a gas. It's the substance that's being dissolved. Think of it as being in the smaller amount. So back to our saltwater example, this would be your sodium chloride would be your solute. Your solvent can also be a solid, liquid, or gas. And this is a substance that the solute is being dissolved in, and it's typically in the larger amount. So think about the water that's dissolving the salt. We always think of the water, or water in general, as being your universal solvent. It can dissolve most things, but the exception to that is it dissolves most things that are polar. It's not going to dissolve anything that is nonpolar. When we dissolve a compound into water, we consider it to be an aqueous solution. So when we're writing this in an equation, we would use the AQ abbreviation for our state of matter. Love me a flow chart. We can organize all matter into two categories. So it's either a pure substance, which you've talked about, those are your elements and your compounds. They have uniform physical properties and chemical properties. And then we have mixtures. So these are substances, they can be elements and compounds, they can be pure substances that are physically mixed together and can be physically separated. There are two types of mixtures, and we'll talk more about these on the following slides, but we have homogeneous mixtures, which have uniform compositions, so they look the same throughout, and we have heterogeneous mixtures, which have a varied composition. So thinking back to my salt and pepper shaker analogy, the salt and pepper mixture would be a heterogeneous mixture because it has a varied composition. You can see the salt, you can see the pepper. So we will also go into what a suspension is, which is a type of heterogeneous mixture, and then also what solutions and colloids are and how those are different. All right, let's get into our types of mixtures. We'll start with homogeneous mixtures. So these are going to look the same throughout. There are solutions and colloids. So we're going to be focusing on both solutions and colloids as types of homogeneous mixtures. And if you have a solution, you have very small particles, you could not separate these using a filter. So you couldn't pass, say, salt water through a filter and expect to extract out the salt from the water. These are typically transparent. The particles aren't going to settle out, so you're not going to see a collection of your solute particles at the bottom. And some examples of these would be air. Air is a mixture of a lot of different gases. Remember that a mixture, the solute and solvent can be solid, liquid, or gas. They can both be gas. So another example would be fillings. We see teeth fillings here, which are a mixture of silver and mercury. So now we're talking about two solids, or a solid metal and a liquid metal, that are serving as a solution. Saline solutions, like what you would find in an IV bag, contain dissolved sodium chloride in water. So that's an aqueous solution of saline. Vinegar, coffee, gasoline, those are all considered solutions. Colloids are homogeneous mixtures, but they have larger particles than your solutions. So because these particles are larger, they're often opaque in appearance, so you can't see through them. You can't separate out your solute from your solvent using filters. The particles are still not separating out. And some examples of these would be proteins, aerosols, foams, emulsions. Milk is probably the one I can imagine the most, so that I put the picture there. Again, milk is going to be a mixture of sugars and proteins and water, but we can see that it doesn't settle out, especially when it's been homogenized. So homogenization makes sure that it stays uniform and that you don't get a separation of that fat and the other parts of the milk. Shifting over to our other type of mixture, we have the heterogeneous mixtures, which are varied composition. So suspension is a type of a heterogeneous mixture, and it's going to have large particles suspended in liquid. Again, these are much larger particles than what you'd see in a solution or a colloid. You can actually separate these out using either a filter or a centrifuge. And a centrifuge is a machine that spins a liquid at a very fast rate. And so whatever the heavier particles are tend to go towards the bottom of your tube, your centrifuge tube, and the lighter particles are on top. These will settle out if you let them sit. And I'm thinking about calamine lotion, if you ever were unlucky enough to have the chicken pox, or if your parents used this when you got bug bites. Milk of magnesia, all of these have directions to shake before using. And that's simply because the larger particles have settled to the bottom and you want to make it a more uniform solution. Amoxicillin as well, when you get the liquid amoxicillin that you keep in the fridge, that settles out as well. Blood is another example of a suspension that we don't usually think about as being a suspension, but it does have larger particles. It has plasma, which are your salts, water, and proteins. It has white blood cells and platelets, as well as red blood cells. And if we were to spin that in a centrifuge, we would wind up with a tube of blood that looks just like what you're seeing in this image, where your heavier cells are towards the bottom and then your plasma is at the top, your lighter part. You can separate them that way. And we've really already talked about all of this, but I just wanted to put some visual examples onto our flow chart in terms of what the solution is versus a colloid versus a suspension versus an element in a compound. So this might be a good one to take a picture of and jot down in your notes.